Is radio frequency welding the same thing as induction stoves? Which, by the way, this isn't an induction stove, it's just an electric stove, but I will be gesturing to it as if it were when I talk about induction. I'm going to tell you where you're not right, but you're really, really close, because this thing, which is a magnet, by the way, a cow magnet, and this thing, electricity, are very, very similar. They are not the same thing, but they are based on the exact same principle, which is electromagnetics. Last night I said that RF welding worked by pressing plastic, which is polar, PVC plastic, in between two pieces of steel, and then a charge is passed through it. This is B-roll footage of me actually buffering time to determine whether I should leave that bit in about an electric current being passed through it, because it's not exactly an electric current, it's an electric charge that is changing, but for the purposes of trying to understand this, I'm going to leave it. Since the plastic in question is polar, that's what makes the difference. Just like in a microwave, the only way you can heat something up is if there is water, if there's a moisture content in it, because water is polar. I don't mean like polar bears, I mean that the molecules are heavier on one side than the other. They're not perfectly like straight across. If you were to try to do a mental image, one has a lot more of a charge on one end than on the other. So if you pass a magnet over it, they're going to flip-flop, or if you pass a current over it, they're going to flip-flop. So in both RF welding and in microwave ovens, you are harnessing the actual motion of the molecules moving and spinning as you are passing a current over them, a charge over them. That creates heat, and it binds the plastic, or it cooks your coffee or your soup. An induction stovetop works by changing electric current in there, changes the magnetic field in each of the burners, and the change in the magnetic field pushes the charges in nearby metal, which creates eddy currents. They're swirling currents that kind of don't do any work except to make heat. They create heat as a byproduct, but we use it while we're cooking. In your internal combustion engines, eddy currents are created incidentally as kind of a waste, a byproduct. They're called eddy currents because they aren't doing a useful current type thing. We use currents all the time and stuff, but eddy currents really are just eddies. So really similar background principle between an induction stove, induction heating and cooking, and the polar switches being used in a microwave and in RF welding. And to be completely candid and completely honest, electromagnetics is something I find fascinating, use all the time, but I have a very difficult time teaching about because I don't understand it like a third grader, which is what you need to do to be able to explain it like a third grader. So I'm constantly learning, and if anybody wants to chime in the comments, I know my inspectors are in here somewhere, please do add any help wherever you can. By the way, this is a cow magnet. I got it at the farm and feed store. It's great. I mean, it rolls down the fridge, but if you put it on this way, these are incredibly strong. They give these to cows to swallow, or they jam them in with like a special gun, and it goes down into the reticulum because of the shape and where the stomach is in the cow, and then the lining inside of the stomach. It holds on to this for life, and it attracts all of the metal bits that they eat accidentally and gives them hardware disease. Cows can get hardware disease because of eating, like, barbed wire clips and whatever falls into their silage or into their hay. So this holds on to it, and at the end of their life, if you pull out a cow magnet, it's got all this metal stuff they've ever eaten. So induction and RF welding, not the same thing. RF welding and microwave ovens, close cousins, siblings.